Hi everyone, thanks for joining this video on how you can amplify the security of your AKS deployments using Ratify and Gatekeeper. I'm Alex, I am a product manager here at Microsoft, and I'm joined by Josh, who is a senior cloud advocate also here at Microsoft. To start things off, what is image signing or verification? I'll give some brief context here on private key infrastructure, or PKI, if you're not familiar. I like to think of this in terms of two main user personas. First is the container image producer, and second is the container image consumer. Let's say, for example, I am a Python image producer. I will build the Python image and create a public key, also known as a certificate, as well as a private key. I'll then sign that Python image that I've built using the private key to create a signature. The signature is attached to that Python image that I've built. I then distribute that Python image alongside the certificate, again, remember the public key, and the attached signature. Moving on to the image consumer, let's say Josh will then take that public key or certificate and that Python image that I've distributed. Josh will then use that public key to validate the signature against the image. Now you might be wondering, why should I be signing my images? First is authenticity. Signing images assures that the images you acquire came from a trusted source. So going back to the example, Josh knows that the Python image that he consumed from me actually came from me and not someone who is pretending to be me. Second is integrity. This means that signing images assures that the images you acquire haven't been tampered with after creation time. So Josh knows that by validating the signature on the Python image, that the image hasn't been tampered or modified in some way between the time that I built the image and distributed that image, and finally when he consumed or acquired that image. The tool that we recommend here to sign images and generate those signatures is the Notation CLI from the Notary project. All right, so you might be signing your images and validating the signatures of the images that you acquire, but how do you ensure that only signed images are deployed to your AKS clusters? That is, how do you ensure that how do you ensure images that were not signed are not on your cluster? We recommend here to use the Ratify tool. Ratify is an open source tool that validates signatures prior to image deployment. That way, it ensures that only images with validated signatures are deployed. How it does this is by communicating with the open source Gatekeeper tool on Kubernetes and by retrieving stored certificates in places like Azure Key Vault. This is the demo architecture that Josh will walk through. So starting off with the Azure Key Vault, inside the Azure Key Vault stores the certificate and the private key associated with that certificate. Next, Notation CLI will use the private key to sign an image stored in ACR. That signature will then be stored alongside that image and attached to that image in ACR. Next, Josh will show the attempt to deploy that signed image using Ratify. Behind the scenes, Ratify will use a managed identity to retrieve the certificate and validate that signature on the image. Upon successful validation, that image will be deployed to AKS. So that is the ideal happy path golden scenario. But the interesting scenario with Ratify is the next scenario, which is deploying an unsigned image. By deploying an unsigned image, Ratify will again attempt to validate the signature on the image. Since there's no signature there, it will fail validation and block the deployment of that image. That way, the image does not end up on your clusters. I'll now hand off the demo to Josh.
In this short demo, you will learn how to use Ratify, an admission controller, to prevent unsigned images from running on your Kubernetes cluster. First things first, let's install Ratify. We'll add the Ratify repository to Helm, and then we will use the Helm install command to install or deploy Ratify to the Kubernetes cluster. Now, by itself, Ratify isn't going to do anything. It needs to have a constraint template that allows you to define the policy that Gatekeeper is either going to validate or invalidate. And then that is what Ratify will use to determine whether it can admit a particular pod or deployment to the cluster or not. So this is actually being handed down, this constraint template's being handed down from Azure policy down to the Kubernetes cluster. And it's essentially just checking if the success criteria is true. And it's essentially looking for a signature that is valid existing on the OCR artifact of the container image that's deployed. So let's look at what happens when we deploy an unsigned image. We'll immediately get this forbidden message from the admission webhook. And if we take a look at the logs, we can see the reason was it failed to verify the object. And if we know a little bit more about the template that was used for this configuration, we would know that it was simply because there wasn't a valid signature attached to the container image. So let's go ahead and see what a successful deployment looks like. To do that, I'm going to need to get the key ID for the signing key ID, which is hosted in Azure Key Vault. So I'm simply using an AZ CLI command to get that KID. And then I'm going to use Notation. Notation will create a digital signature on the container image artifact in the registry. And to do that, we can use the Notation sign command. And you can see the different options that are passed in here. But I was able to successfully sign the image. And now we will rerun the signed one. And we can see that it didn't get that forbidden error and it was allowed to deploy the cluster. We can verify that with using the kubectl git pods. And then also checking the logs of the deployment. And we'll get more information about the verifier reports from Ratify and Gatekeeper in the logs here, the Ratify logs. And so we can even see here in the logs a little bit of the information about the signature itself. So in the end, what Ratify really gives you is confidence in knowing that the container images that are being run on your clusters came from a trusted source, or at least came from where you think they came from, which is a good step forward. If you would like to learn more about Ratify, head over to ratify.dev.